So, MCP servers. What are they? How do they work? And why should you care? In this video, we'll be diving into MCP servers, the problem that they help solve, and getting hands-on with some MCP servers that AWS has recently released to make it easier to build on AWS. I'm Kevon Mares and I'm a solutions architect. Let's hop right into it. So if you're watching this video, GenAI might not necessarily be brand new to you, but let's dive into some of the core concepts a little bit more. Now, what you're likely interacting with if you're using GenAI on the day-to-day is a foundation model, or an FM. Companies like Meta, Amazon, and Anthropic have trained these foundation models on a vast amount of data, and really, they're configured to be specific to certain use cases. You might have some that work a little bit better for text-based workflows and use cases, some that are a little bit more for video or for photos, and then some even for audio. And there's also some that are multimodal models, which is a little bit of a tongue twister if you try to say that 5 times. But really to combine and be used for a variety of use cases, right? So not necessarily going to excel in just text or just audio or just video, really combining those and giving you some flexibility in that type of applications you would build with something like that. So like I mentioned, these large language models, they've been trained on a vast amount of data. Companies like Meta, Anthropic, Amazon, they've invested a lot of time and resources into training these models, right? So why might you be even considering using something beyond just a base foundation model? The problem really comes down to context. So when a large language model is trained, it's trained on data that it was provided up to a certain point, right? So if you think about, maybe a large language model that might have some information about some documentation for a programming language that you're working on or a framework, it's going to know up until that point. And say a major release comes out right after the model was trained, well, until there's another version of the model that you can use, it might not necessarily give you the most accurate information if there's been a major breaking change or something along those lines. And I think this is especially relevant for the technology industry. Things are always changing, information is always being updated and advanced on, so you want to make sure you're always getting the latest and most up-to-date information. And that really brings us to part of the problem. With these large language models, and depending on what you're trying to do, it might not necessarily have the most up-to-date and accurate information, which can lead to what's known as hallucinations. Hallucinations are basically when you get a response from an LLM and it's not necessarily accurate, right? It could be giving you maybe correct information up to a certain point, but maybe it's not correct in the context of today versus last year or versus a couple months ago. So you might be thinking, well, what are my options, right? If this LLM might not necessarily have the most up-to-date and accurate information, do I have to go train my own LLM? Now, if you have the time, money, and resources, by all means, right, go train your own foundation model. But for the vast majority of people, that's not practical, right? There's other better ways that you can effectively get what you need from an LLM. And that brings us to one of the solutions, which is RAG, or Retrieval Augmented Generation. Now, if you break that apart, it makes it pretty clear on the point of this, right? Retrieval Augmented Generation. So you want the LLM to be able to augment what it's retrieving and generating for the response. And the augmentation that you want to provide is going to be additional data, right? So think about it. If you have, you're working in a company and you have your company specific data, and you want to make sure that the LLM that you're using internally is going to have access to that company data. And when a user passes in a prompt to the LLM, it can augment what it is going to fetch for the response with the most up-to-date and accurate information that you're supplying, or maybe even contextual information that's a little bit more relevant to your company and the industry that you're working in. RAG really started to help these organizations reduce hallucinations and improve the confidence in the responses that the LLM was providing. And this really helped increase adoption, right? As much as people are interested in new technologies and new innovation, if you pass in a prompt and you can't have a degree of confidence that the response is going to be accurate, well, that's going to limit the widespread consumption and adoption of the technology. So the next natural phase was, how can I make it do more, right? I'm always submitting these prompts and waiting for a response. Is there a way that maybe I can have it maybe do things with concurrently, right? Maybe I want to pass on a prompt and I want it to be able to look at a variety of different locations to be able to give me an ultimate response. Or maybe I actually want it to take action on my behalf. And this is where things like AI agents start to have a little bit more relevance. Now, these AI agents are really just software programs that are designed to interact with their environment and really do things that are a little bit more complex. These are things like problem solving, right? Given some context of the situation, being able to formulate potential solutions, decision making, being able to, from the choices that are available that is determined, actually make the most logical, decide the most logical path forward from those choices. Communication between these multiple AI agents, being able to share and pass information and do things that are a little bit more complex and do them concurrently. And finally, actually interacting with applications and doing things on your behalf. So let's take an example. Imagine it's your friend's birthday that's coming up soon, chatting with an LLM, and you want to help make a playlist that you can play at the party. You might give it some contextual information on, hey, these are their likes, these are their dislikes. Can you help me make this playlist? And what the LLM could then do is, based off the data that it was trained on and the data that you feed in through the prompt, help you generate maybe 10, 15, 20 songs that you can then add to the playlist and play at the party. But really, for most people, that's kind of where it stopped. You would get the response, you would get the instructions maybe in the list of songs, but you would have to actually take that action to go about making the playlists in Spotify or Apple Music or whatever you use for streaming. But what if you could do more than that? What if you could use AI to actually do that action for you? Now, with AI agents, that is something that could be possible, but really it was some custom logic that you had to put in to make that functionality work, and it wasn't standardized, right? If you write functionality for one application, that didn't directly translate to another application. So it leads and really led to, what is the next step? How do we make this easier to make these interactions with all these applications and without having to write this and rewrite it for application to application to application? And that brings us to MCP. MCP stands for Model Context Protocol, and it is as it sounds. It's a protocol, a standard, an abstraction layer that makes it easier for AI agents and models to communicate with external data sources and tools and even applications. So for a more visual example, think of it like a bridge or like a USB hub. With a USB hub, you can plug in a variety of completely unrelated devices. You could plug in an audio interface, which has a series of microphones and compressors and EQs and monitors through it. You could plug in something like a printer. You could plug in a camera, right? But it's going to really provide you with that unified interface to take all of those variety of different sources and feed it into a target, which in this case would be a computer in the context of a USB hub. It's a really similar thing to what's happening with MCP and MCP servers, which we'll touch on in a little bit. So one of the main benefits that MCP provides really is that standard protocol, right? The way I kind of rationalize or draw parallels to is an API, or application programming interface. So an API is really just an abstraction layer that allows two entities to talk to each other. For a practical example, imagine if you're on Amazon.com and you're going to buy a product, you search, you add it to the cart, and you want to check out, right? You're not actually having to write the interaction that's going to allow you to talk to, assuming a series of servers that is making Amazon or hosting Amazon.com. You don't have to write that interaction, right? You use a standard way that you can interact with Amazon.com and buy your product. And then say if, hey, you want to go buy something from BestBuy.com, you don't have to have a completely different way that you then interact with BestBuy.com to go ahead and check out and purchase your order and get it delivered or do the store pickup, right? That's one way that I kind of think about it is that interface layer, and really what APIs provided is for developers to have standardized ways that they could allow clients on or users on the client end to talk to backend services on the server side, right? And the same really applies for MCP servers, right? You would be using some sort of an MCP client, so something like Klein or maybe Cursor, on the the client side or the front end side, and then on the back end or the server side, you would have an MCP server that's actually going to be performing the core of the logic that you want it to actually do. So that's enough theory for now. Let's hop over to my IDE and we'll get hands-on with some AWS MCP servers. All right, so I'm at my computer, and like I mentioned, AWS has created a number of MCP servers that you have available for use. On this Git repository, and don't worry, I'll link this in the video description, but you can see here, it starts with some table of contents, so going over some of what I've already touched on the video, but likely in a little bit more depth. And then if you scroll down, you can actually see a list of MCP servers. So there's one like the core MCP server, another one for AWS Docs, and some stuff for Bedrock, CDK, cost analysis. But the one we're going to be using is all the way at the bottom, is actually the newest one, which is the Terraform MCP Server. So I'm going to flip over. For today, I'm going to be using VS Code for my IDE, and I'm going to be using Client for my MCP client. So let's hop over to VS Code. And what we're going to do is we're going to install the Client VS Code extension. Similar should be available for any other IDE that you're, any other supported IDE that you're planning to use. So in VS Code, you're going to click this button to look for the extensions. You're going to search for Client and click on the option that has this logo, and it should say client.bot. And then you're going to click install. Now I already have it installed, so I'm not going to uninstall it and reinstall it. The next thing that you would do is you would see a little icon in the extensions down here pop up once it's installed, and you would click on that. Okay. Now I've already been signed in and things like that, but what you might see if I just go ahead and log out is this sign up with Client. And if you click this, it should take you into the web browser, and it should prompt you. This is already because I've somewhat already signed in, but there'll be two options. One is for Google, and then another one was with GitHub. This is for GitHub for me, because you can see I'm already signed into GitHub and I've already signed into Client. And then you would just click authorize. Then I'll redirect back to Visual Studio Code, and let's see here. I think that should be good. And yeah, you can see my profile and all that stuff that's been pulled over from GitHub. Now, what I would say is with Client, the way that it works, there's a variety of APIs that you can use in terms of what you want to actually use for the MCP server. You can use Client itself, but what we're going to be using is Amazon Bedrock. So really, if you do create a Client account, you can probably just make one that's on the free tier, because all the API requests, for the most part, are all going to be flowing through Amazon Bedrock. All right. And once you're signed in, you can click done, and you should see a chat. You can see some of my previously ran prompts. So the next thing what we're going to do is let's actually configure Client to use Amazon Bedrock. So what you're going to do is at the top, click the little settings gear, and then you want to change the API provider from Client to scroll down to should be Amazon Bedrock, but AWS Bedrock. We'll select that. And then you can see there's two options you have here. You have either AWS credentials, where you have secret access keys and the secret key and then the session token, or you have AWS profile. That's what I'm going to use just because it's a little bit easier, and you get the token that automatically renews and things like that. So set the profile, and this would be something that you'd have to have set up in your, it would be in your .aws directory on your local machine. You would set this up by running the AWS configure CLI command. All right, so I have my profile set. I am going to be using US East 1. I'm going to make sure cross-region inference is selected. And then the model I'm going to be using today is Anthropic's Claude 3.7 Sonnet. And then scroll down, and then you can put in some custom instructions. So what I basically have is, for every new project, always look at your MCP servers and use the MCP core as the starting point every time. Also, after a task completion, include a list of MCP servers used in the operation. And then there's a last little bit here. Also, if I mention anything about Terraform, use the Terraform MCP server. All right. And I believe that's all that we have to do on this page. Okay. All right, so all that looks good to me. So I'm going to go to the top and I'm going to click done. And then you should see your client chat after that. Now the next thing that I want to do is I want to configure to actually use the MCP servers that are available to me. So what we can do is click this little servers icon at the top of the page here. And this will bring up a window where you can search for MCP servers in the marketplace. So if I search for AWS, you see some of the ones that were in that Git repo. But you can see the Terraform one isn't here. Some of them aren't up on this marketplace just yet. So what we're going to do is go to the installed tab and then click configure MCP servers. And that's going to open up this client MCP settings.json file. And this is where you can also define the MCP servers. Now, if you go back to the Git repository and scroll down, there's some code snippets on how to do some configuration, but specifically there's one with getting started with client and Amazon Bedrock. So if you expand this little drop down, you can see some of the stuff that I've already mentioned, like searching for client, installing, clicking configure servers. But what's actually helpful here is there's a code snippet that you can use. So I'm going to click this code snippet. I'm going to go back over into VS Code and I'm going to replace the whole file with this. And what you can see is there's 3 MCP servers. There's the core, there's one for Amazon Nova, and then there's another one with for Terraform. I'm going to fix this error by just getting rid of that last trailing comma. But we're actually not going to be using the Nova one. So I'm going to remove that for right now. We're only going to be focusing on using the Terraform MCP server and then the core server, which is also recommended. So to actually install the MCP servers, just save the file. And you can see now at the bottom it says updating MCP servers. So we'll give this a little bit of time. Okay. And then you should get these you should see these 2 MCP servers. They should be enabled and all that should be good to go. All right. So the next thing that we can do, we've set up client. Let's take a look at the directory that we're in. So you can see bare bones, just an empty directory, nothing here. I'm going to go ahead and close these files as well. And let's open up client chat and let's just try to start small, right? Let's try to do some stuff that maybe you're familiar if you're already using, an LLM to generate some Terraform code. So we'll just say, we'll try to tell it to specify the Terraform MCP server. So use the Terraform MCP server and create me a VPC with 2 public and 2 private subnets. Use a reasonable IP range for the VPC and subnets. And I'm going to push enter. And you can see that kicks off an API request, and we'll wait for that. Okay, and you can see that it's giving a summary of what it knows it needs to do. So it needs to create the Terraform configuration for VPC with 2 public and 2 private subnets. And then it wants to use the Terraform MCP server. So at the beginning, you can see that it wants to use the core MCP server, and that's what we want to do. So the core MCP server is part of what it does is help orchestrate between the other MCP servers if you're using multiple of the AWS MCP servers together. So I'm going to approve that. And you can see that kicks off another API request. All right, and now it says that now that I know to use the MCP core, I have a better understanding. It gives a list of, I want to create these files. It's making this main.tf file. And once it finishes, and you can see this is pretty similar if you use Git and kind of reviewed changes in an IDE. You can see kind of like the additions in the green versus any deletions in the red. So it's giving you an example, a preview of what it's making, and you can see it is doing it right. It's making the VPC, a little basic provider block, resource subnets, etc., etc. That looks fine to me. Let's see some route tables, associations. Cool. We'll keep that for now and click save. That's going to kick off another API request. And now it says that I need to create the variables.tf file. to get rid of those errors and of what was referenced in main.tf, and that looks fine. It's telling us the VPC CIDR range is going to pick, and that looks good. I'll click save. Okay, next is going to create some outputs, right? So some helpful outputs if we need to reference this somewhere else later on. Save that. Right, now it's saying that now that I've made the core files, I should validate the configuration and make sure it's correct. And it's saying I want to use the Terraform MCP Server, and that's correct. And you can see what it wants to do is an init, and it looks like it's pointing to this initial directory, which I believe is, yeah, the files are right at the root level of this. So that should be fine. I'm going to click approve. Okay, and it did a Terraform init, and now it's saying it wants to do a Terraform validate. All right, the configuration is validate. Now it actually wants to do an execute command for the plan. So let's see if this works. This may or may not work because, so one nuance I want to touch on is, so we configured the AWS profile here, right? This is for client's use case, right? When it comes to similar to like if you open a new terminal session, you have to authenticate again in terms of like your AWS profile or environment variables or anything like that you would set. So these are separate, right? What you have in your terminal session here versus what you have in client is a different set of credentials. So since I haven't logged into an AWS account in my terminal over here, it might throw an error saying that it doesn't have any credentials, but let's just see. I'm going to let it try to do the plan. Yep, and it's erroring out saying that there's no credentials. So let's see what it's going to try to do now. So it's saying we can't run a plan without valid AWS credentials. So let's go ahead and at least try to do a security scan, and it's going to be using Chekhov to do this. Again, using the Terraform MCP Server. So let's approve that and at least get some validation in terms of the security of the code that was written. Okay, and that's looking like it's scanning the file. And it says Chekhov found 4 issues in the Terraform configuration, and it's showing the specific checks. And it's actually going through and fixing the code that it wrote to address what was called out in the failed Chekhov test. So you can see there it's deleting and modifying and adding some new ones. And now it's saying I could save it, but what I want to say is actually just add Chekhov suppressions instead of modifying the file, modifying the resources in the files. This is just a simple test. And we'll kick this off and see what it's going to do. So you can see first off, it disregarded all those changes since I didn't click save. And now it's going to create those Chekhov suppressions. So if you can see, it actually went in and it created the Chekhov suppression. So it added 2 there for the, I believe for the VPC. Now this might be a small, let's see if it's going to actually know, this needs to, I believe, be inside of the VPC block. And then only added 2 of them. Let's see here. For the main.tf public subnet, we'll click save, and I want to continue on and see what the response is going to be. I believe next is probably going to try to, okay, so now it's doing the next step. So it wants to add a Chekhov suppression for the subnets. That one, again, they put it outside of the resource block. So I'm going to save it and see if it's going to pick up on any of that later. So now it's trying to run the Chekhov scan again to verify suppressions are working. So it's going to rerun Chekhov. Let's see what it does this time. And it says the Chekhov suppressions aren't being recognized. Of course, I know that's because they're not inside of the resource block. But let's see if it's going to be able to determine that on its own. Okay, so the format might be slightly different than what Chekhov expects. Let's try something else. Let's see. Looks like it's doing a retry. so the suppressions will be placed directly above the resource declaration is what they're saying. Let's update with the correct format. Okay, so it fixed it. It put it inside of the resource for that. That looks good. I'm going to give it the validation that what it did was correct. And now it's probably going to go and try to change this subnets one. And yep, it went ahead and it fixed the one for the public subnet. And I'm going to click save. And now it's going to rerun checkoff scan. So I'll prove that. All right, now it's saying that checkoff passed. And now it's basically starting to try to wrap some things up a little bit, making a README, explaining the code that it generated, and even giving some instructions to go ahead and execute the code if you want it to. And that looks fine, so I'm going to click save. All right, and now it's saying that it wants to try to do a Terraform validate, so to make sure that it's correct. And looks like the validate was successful from the response, but we'll wait for it to write it out. All right, configuration is validate. And now it's basically going to summarize what it did as a final kind of closeout for this specific task. All right, and then if you click this, if you were to click this See New Changes button, it'd be similar to like like what I was showing earlier, the kind of green changes versus red deletions, etc. But I'm not going to do that. I want to actually see if we could do something a little bit more complicated, right? Like that works, you know, but that's not necessarily, besides it actually writing the code for you and generating the files and things like that. It's not super far off from what you might be able to do with an LLM, you know, right now. The checkoff thing is definitely nice though, right? And even, you know, adding the suppressions or even modifying the code to fix the security findings, right? That is something that's really nice, and kind of the action that it can take on your behalf. Let's see if we can do a little bit more. So what I'm first going to do is I'm going to remove all these files. So main.tf outputs, some of these aren't here. Like main outputs and variables in the README are the only ones. So run that, and that's all cleared out. Close all these files. And what I want to actually try to do, right, as a Terraform developer, one thing that's generally pretty common is to go find an existing Terraform module that you might want to use, instead of starting directly from you know, standalone AWS resources or resources for any provider that you're working with. So what I want to do is I want to reference a specific public module on the Terraform registry and have the Terraform MCP server create a configuration based off of what's possible using that module. So what I'm going to do, I'm going to flip back over and I'm going to look at one of the Terraform modules I created for IAM Identity Center. Me and a good couple folks at AWS and some external contributors. I'm going to grab this URL because this is what I'm going to want to feed into the prompt. I'm going to click Start a New Task, and I'm going to say using the Terraform MCP server, create a user named Kevon Mayers who is in a group named admin. That group should have admin permissions to an AWS account. I will give the account ID later. Use this module. All right, and let's see what it does. All right, and it's saying similar as before what it needs to do. It's saying it gets it is aware of the module URL that I passed in. I'm going to click approve. That way I can use that MCP server. All right, and then again, giving a plan of what it's going to be doing based off of what it had so far. So you can see it's actually doing the exact module declaration that's expected, and it's creating the variable assignments for what the module expects, right? So for this module, right, or any Terraform module, right, you're gonna have a source, and then you can reference a specific version for something that's publicly hosted. And then for these variables, right, exactly what I wanted. I said I wanted a group called admin, then they have one called admin with a description, and then I wanted a group called a user called Kevon Mayers, and they were even intelligent enough, this MCP server was intelligent enough to fill that in with a username that would make sense, right? Common naming for usernames is going to be first initial, last name, and then they even made a sample little email address, for me. And then they also have that permission set and the account assignment, which I said I would provide later, and they even, it even made abstracted that away to a variable, which is nice, and what I likely would have already did myself too. So I'll click save. That file is now saved, and you can see there is a small error only because that variables file isn't created yet, and that's the next logical step, is to create that variables file. So it has one with the AWS region, made one for the AWS account IDs, and it's not giving, it's not specifying a specific account ID because I said I would give that later, right? So I'll click save. Okay, and it says now it's going to create an example.tfrs file. So they're not creating the exact file that you would actually use during a Terraform apply, but it's given just an example one to show you, hey, this is what it would look like. And it's even given some really helpful inline comments to tell you what you would need to modify in actuality. So I'll click save, and you can see now it's going to create the outputs. Click save. And now it's going to wrap up by making a README. So again, similar as the previous example, doing some documentation, showing some instructions on how you could actually apply this. Save. And then now it's going to continue to check the work. So it's going to run Terraform validate. And it actually realized, oh, the module is not yet installed. Now, this is a small little thing with the, this is not with the MCP server. This is something with Cline and VS Code. Haven't been able to resolve it. This error basically occurs sometimes when Cline isn't aware of the output that was in the terminal. You can see a little notice about it right here. I've tried everything that they listed on their GitHub, but I haven't been able to resolve it. But yeah, this is just a Cline specific thing here. So it's saying that it wants to try to do a Terraform init. So I'm going to run the command. And you can see it's doing the Terraform init. That was successful, but again, it's saying it doesn't know the output from the init command either. And then I can actually help it along its way a little bit. It was successful. This was the output. Pass it in and let's see what it does. All right, and now it's saying great, the init was successful. Now I can summarize what I've created. Task completed. It's wrapping up. And the task is complete. So those were just two examples, right? And I really want to highlight that that's just kind of scratching the surface of what you can do with this Terraform MCP server. It can do things like code conversions, right? If you needed to move between maybe different infrastructures, code platforms, it could be something that if you needed to maybe refactor something from standalone Terraform resources into a module or things like that. Like I really would say, take this, see how it could work into, or you can implement it into your workflow and just see if some of the benefits that it can provide. It's definitely something that in my testing has been helpful and it's generally been writing code and doing things in the way that I would want for the most part, right? So yeah. So that about does it for today's video. Hopefully you got a good introduction into MCP servers, a little bit of the theory and kind of history of generative AI, and start to see some of the practical use cases for an MCP server. I definitely would say this is really just scratching the surface of what's possible with an MCP server. So I would say take it as a challenge, right? If you want to learn a little bit more about the technology and how it works under the hood, take a poke around in the GitHub repo that's going to be linked down in the description below, and look at the open source AWS MCP servers and kind of see how they're configured, right? Look at some of the code that's there, look at some of the structure, and maybe take it as a project to make your own MCP server. If you found this video helpful, please like, comment, and share to others that you think might get some value from it. And if you're interested in more videos like this, feel free to subscribe to the channel and stay tuned for more. That's all for now, and I'll see you in the next one. Peace.